Let's look at OpenStax University Physics Volume 2, Chapter 16, Problem 60. Assume that helium neon lasers commonly used in student physics labs have power outputs of 0.5 milliwatts. If such a laser beam is projected onto a circular spot 1 millimeter in diameter, what is its intensity? B. Find the peak magnetic field strength. C. Find the peak electric field strength. So let's write down the things that we know and the things we're looking for. So we know that the power is 0.5 milliwatts. We know that the diameter of the spot is 1.00 millimeters. And in part A, we're looking for the intensity. In part B, we're looking for the peak magnetic field. And in part C, we're looking for the peak electric field. All right, so I already have my equations here. So I know that the intensity is the power divided by area, and then I know that the intensity is the speed of light times permittivity of free space times the square of the RMS electric field, or the intensity is the speed of light divided by the permeability of free space times the square of B RMS. So let's draw the picture as best I can. So here's a laser beam, and it's striking a little area, and that area has a diameter of 1 millimeter. So that means that when we're solving for the intensity for part A, that's power divided by the area. The area in this case is just the area of a circle, because the spot here is a circular spot, so the area we're dealing with is the area of a circle. So this will be the power divided by pi r squared, or the power divided by pi d over 2 squared. So that is 4 times the power divided by pi d squared, and that is 4 times 0.5 times 10 to the negative 3 watts divided by pi 3.14 times d squared. So that is 1 times 10 to the negative 3 quantity squared, and we get an intensity of 637 watts per square meters. Then in part B, we're looking for the magnetic field, the peak value of the magnetic field. So I'll use S is C over mu naught B RMS squared, and I know that B RMS is B naught divided by square root of 2, so I have to square this. So that will be C over 2 mu naught times B naught squared. From here, I get that B naught is square root of 2 mu naught divided by C times S. So when I plug in the numbers, so I have B naught is square root of 2 4 pi times 10 to the negative 7th Tesla meters per amps. Intensity is 637 watts per square meters divided by 3 times 10 to the 8th, square root of that. And we get a magnetic field of 2.31 times 10 to the negative 6th Tesla. In part C, now we want the electric field, and we know that the intensity is C epsilon naught E RMS squared. So that is C epsilon naught E peak divided by square root of 2 quantity squared. So that is C epsilon naught E naught squared divided by 2. So the electric field, the peak electric field, will be square root 2 times the intensity divided by C epsilon naught. So when we plug in numbers, we have 2 times 637 watts per square meters divided by 3 times 10 to the 8th meters per second multiplied by 8.854 times 10 to the negative 12th, and we have to take the square root of this. And we'll get a value of 693 newtons per coulombs for the electric field.